Sorry, I had myself muted. We wanted to thank you all for coming here today. We are the Flooding on Tribal Lands group. My name is Bree Stone. I'm from Front Range Community College. Also in our group is Shauna Lawrence from the United Tribes Technical College and Jesse Joseph from the Ogallala Lakota College, of which, just for a quick explanation of this photo is actually from the 2019 floods on Standing Rock Reservation. Next slide, please. So for this project, it was given to Stephen Tangen, who is with the North Central Climate Adaptation Science Center. And the goal of this project was to actually be able to create a map a very big issue. Some of the different issues that causes for society is land erosion, road loss, as you can see in the photo on the slide, property damage, land loss and degradation, which is different than land erosion. This is where the land has been destroyed or degraded to where it can no longer be used for the purpose it was available to be used for prior to the flood. And then another concern for the reservations is also cultural resources. So our hope would be able to create these flood risks, or be able to create a flood risk map, is to enable the tribes to be more prepared for whenever floods do come along, and even more importantly, be able to identify what road segments are at risk of being damaged or destroyed due to floods, because there were times during not only the 2019 flood, but also previous floods to where individuals or communities were cut off from resources due to the roads being taken out by the floods. Next slide, please. So for this study, we were initially given 4 different reservations to do analysis on, which were Flanderoo, Santini, Pine Ridge, Rosebud, and Standing Rock. And also when we originally received this project, our goal was to hopefully also be able to do a drought analysis as well. And so with hopes of doing both flooding and drought, we had chosen to do the Standing Rock Reservation because up there they have a concern for both flooding issues and also for severe drought issues. Unfortunately, due to time constraints, we were unable to do drought, but at least we were able to do flooding for Standing Rock Reservation. Next slide, please.
Hello, good afternoon. My name is Jesse Joseph. I'm an enrolled member of the Sichangu Oyate, Rosebud Sioux Tribe. And our method for this, our study is modeled after a similar study used to create an island-wide map for the island of St. Lucia, which is located on the edge of the Caribbean Sea north of Venezuela. And on table 2 here, we can see the different variables used in the study to create the different risk levels. The runoff curve number is a value used to determine how much water the soil in a given area will absorb versus how much will run off. It's known as the infiltration rate and is based on soil type and land cover usage. These numbers range from 30 to 100, with 30 being the lowest runoff potential and 100 having the highest potential for runoff. The rainfall daily amount for mean annual only used data for extreme rainfall events that resulted in flooding. And the flatter the slope of the floodplain, the more pooling can occur and contribute to flooding. Next slide, please. Okay. Here we see the four layers that we combined the soil data and the land use treatment, and we got the curve number risk, the CN risk, which ranges from 1 to 3, as does the rainfall, the rain risk, and the slope ranges from 1, 2, and 6, and that's due to the fact that slopes are more likely to pool and flood compared to anywhere else that has slope. When added together, we get a risk range, and by combining those ranges together, This is how we ascertained the risk level, with 1 being the low risk and 3 being high risk. Thank you. Next is Shanna with the results.
So as a result, my team and I have come together to start an analysis that will help better prepare infrastructure on the Standing Rock Reservation from future floods. We have built a code, but with the limited time available, the data is not as accurate as we would like. We were unable to perform the precipitation analysis. Our result map is made up of soil, land use, and slope data. Our map includes high to low risk levels throughout the reservation boundaries. As you can see, the higher risk levels are more located around rivers and some cities. With the data we have been given, we hope to minimize the issues of land erosion, road and land loss, property damage, land degradation, and loss of sacred sites within the reservation boundaries. Next slide, please. Next, we hope to include precipitation and run the analysis on all 3 reservations, which again include Blandrew Santee, Pine Ridge, and Rosebud. Since our reference is based off of an island rather than an inland area, we hope to improve the slope values to better fit a land area rather than an island, and also determine the curve numbers for all land types found on the reservations. Finally, we want to confirm that each reservation can run the code. If needed, we will make further changes to the code to reduce memory usage. How we will do this is by breaking the code down into parts for timeout issues or anything else that may occur along the way. Once again, we would like to thank you all for coming and listening to our project, and a special thank you to our mentors, Earth Lab and NSF, for giving us this opportunity. Does anybody have any questions?